So the next component we're going to work on is creating an enemy that wants to chase the player. So the way it's constructed right now is it tries to find the shortest distance or the greater distance, horizontal or vertical, and close that gap. But every time it is blocked in its movement, so you can see it starts to move at a 45, but every time it is blocked and runs into surface, it's going to then wander, much like the wandering monsters, randomly for a certain window of time before it then tries to resume chasing. Now, if it gets blocked for a while and keeps getting blocked, it may have some issues, but you can see how it is wandering. So this type of behavior is a much simpler algorithm than trying to work with a full-on pathfinding or integrating a pathfinding library. So the object is always going to be looking for that path and trying to close that gap on the most efficient or the least expensive path. And that expensive is something that you can learn about if you study pathfinding. So back in our code, what we are going to do is we're going to take the enemy class and we're going to make a new one that extends upon this enemy class. So it's going to use some of what's there and then it's going to have some new information. But by doing that, that means we don't need to redo all of this walking information. And if you do this, then this means we would have two versions of the same kind of sprite. Now, if we, as we are working with it, we will need to keep in mind, what we are making and how we're making it if we're going to work with different sprite sheets as we bring them in. So that will be a consideration if we have a whole variety of different kinds of creatures that we're going to bring into the game, and we may end up having to do a little bit of tweak on the code. The important thing is when you are building separate sprite sheets with different artwork is making sure that your naming is going to be consistent. That's going to keep your life a little bit more sane as you work on it. So the code that we'll be repeating here will be this material that we are going to be adding into it. We're also going to take enemy and we will be adding onto it as well. So we will be passing in type. Let's go, where's my entity as well? So we have type that we already put into it. We just weren't using it yet, but we are going to pass it in as part of the enemy so that we can work with that, because it's going to be useful as we add more into it. Now we can see that's no longer grayed out because it shows that we are connecting those there. Need to make sure I get my equal sign. All right, so that gives me my enemy there. And let me, under the super, put in type there. We'll just save this. I'm going to copy these first three lines here so I don't have to retype them as I make my new class. So this, right now I have my base enemy. And the reason that I'm doing this extension on it is the create or constructor is mostly the same, but update and how it moves is going to be different. So that's why we're going to set it up differently. Again, this isn't the most efficient way of working with it, but it's a way to try and keep things separate and in a logical or easy to understand method. In a full production, large-scale project, we would need to really revisit this concept of inheritance as we work with it. So under scripts, new file, and this will be enemy follow .js. So we put that in, paste, let's change the name. So this is now going to be enemy follow So with a capital F this time. And it doesn't extend entity, it extends enemy. Now, if we want, we can adjust the speed that it's going to work with, so it can make it faster or slower. So I'm going to just give it a little bit more oomph to it. And we're going to also give it another property in our create, which is chasing. Because what's going to happen is we're going to set it up so that it's chasing until it is blocked. And once it's blocked, then it's not going to be chasing for a certain period of time. And at that point, once that expires, then it will resume the hunt. So now, let me just close out the class there so I have the correct curly braces. And we will have our update. And when we do our update, we're going to pass in a destination. So as we passed in that destination, we're going to work with it. So we're going to start out, and I'm just going to put speed equals this, just to so I don't have to write this dot speed as many times. So if I'm chasing, then we're going to do similar to what we've done before. One is we want to fix so we can't go double speed when we go diagonal. So we set our velocity in both directions to 0. And now we need to calculate the distance on the x-axis between the two. So we look for the absolute value of this dot body dot x minus our destination x. Now, we passed into this the player's location. So when we call update, we're going to send to this the player's x and the player's y. And then our dy will be math.absolute this.body.y minus destination.y. And I didn't get destination.key this time. That's good, unlike in the previous video where it broke things, or 2 videos ago, whichever it was. And now we check and see if our distance on the x is greater than the distance on the y, then we want to close x gap, else close the y gap. So we are going to close one or the other gaps as we work with this. If we are chasing, and then let's just get a few more comments in here to make it a little bit easier to verify which of these curly braces, and update, and class, and chase. There we go. So after we've figured out which velocity we're going to go on, we'll take our body and normalize it, and then scale it by our speed. So that's essentially saying we take our movement vector, and if it happens to be close to a diagonal movement, we narrow it down so it doesn't go at double speed. So now, if as we're closing the x gap and closing the y gap, then we need to set another set of ifs in here. Each one of these will have if-else's in it. We need to find out, is the enemy to the left or right of player, because that determines whether we move left or right, and then we will calculate if we're up above or below, and that will determine whether we move down or up. So if the body.x, which we really almost should store body x and body y in values to make this faster for typing, but destination.x, so if the player or the enemy's x is less than the player's x, that means we need to move to the right. Else we need to move left. Same thing over here. So if this dot body dot y is less than destination dot y, that means we're above the player, so we go move down. Else move up. So by putting this in here, it gives us, it's easier now. I know what direction I want to go. So if I'm trying to move right, this dot body dot set velocity x, or we could just do set velocity in this case. So we're moving right, so that means I'm going to move speed 0. So speed comma 0. That means x-axis move speed, y-axis don't move. And this dot anims dot play enemy right true. So in the interest of typing, or not typing anymore, I'm going to paste these in. Paste this in and then change the gritty details. So now if we're moving left, we change this to left, and now you see how useful those comments are when we put those in. And now when we are going to be moving down, that's a positive speed down, but on the y, not on the x-axis. And same thing here, no x, and a negative speed when we want to move up. And then change our animations. So now if we are chasing, this is what we're going to do. So we're going to just stop with the enemy follow right here and save this. Let's bop over here, and actually I'm going to put it right after enemy so I can find it easier. All right, so there we have it. But now if we want to put it in and figure out how we are going to make the enemy chase us, that's where it gets to be a little bit more interesting. So with that, we go into our code here, and let's go find, so we have the plural enemies. We have the one enemy that can't, it hits us, it hurts us, but we can't hurt it. So it's an invulnerable one. Yeah, that's not a bad thing, is if that makes sense for your game. So let's copy that. This is going to be my enemy 2. Now we can see with the enemy that we have going on here, we can pass in values as we do it because it's looking for a type. So I'm going to say I'm passing in a wandering value, and so this wandering, he does wandering 50. And now here, I'm going to pass in wandering 10 for those. But this time, I'm going to pass in follow. Oh, goes in quotes. I'm also going to do something so we can see the difference. So I will tint it green. So using the 0x00ff00, so that tints it green so that we can see it. And we want enemy 2 to collide with the world layer to stay in bounds. So that's good. That's good. Now we also need to, if we are going to make this collide with us, we need to add in a physics collision. And we could use the standard enemy, so the same as enemy right here, but then it would be enemy 2. So this would be enemy 2. And I realize I should have these collisions with, for the projectile should be under my collisions as well, but that means collisions we probably should just move to the very end. We'll save that as an optimization for a subsequent time. So I've now added this in. Let's save our project and see what happens. And there's a green guy. Oh, look. Wait, let's refresh that. And he just takes off wandering. Well, that's not good. He's wandering away. But what we have to remember, and this is something that's really easy to forget when we're doing this, if we go into our update, we can see we're updating the player, we're updating the single enemy, we're updating the other enemies, we're firing projectiles, but we haven't said let's update enemy 2. I mean, it's kind of exciting though when we do this, and well, yeah, we don't get any red error messages. We added something, it showed up. It's like, sweet, we're in good shape. But we also want to, if enemy 2 is not dead, let's tell enemy 2 to update. But let's also, so that it's useful, say this dot player dot body dot position. So we pass that into it. Now let's see. Oh, hey. He started following and moving and is doing some work. It started going. Refresh. So he's wandering, but he's not quite wandering after us per se. So we need to do a little bit more inside of the enemy follow to get that enemy following us. And it's not following us because due to the evils of copy pasting, enemy 2 is just simply an enemy. So if I save this and look, we can see it's just an enemy. That's why it just wanders, just like the white one, and it works its way around. Because we never set the correct class. We need to say it's a following enemy. Now when I do that, I can see it's trying to, oh yeah, it's following, it's chasing me. Oh, shoot, died. All right, so 2 things. 1, we need to figure out how to keep it from getting blocked. 2, I'm going to eliminate the collision with the player for the time being so we can keep it involved in the game a little bit longer. So now you can see how it's trying to follow me, but once it gets blocked, it has a lot of issues because now it's just walking and it can't figure out how to, because it doesn't have any pathfinding built into it yet. And we can see it follows when we get into that 45. That's a little bit troubling, but we're going to live with that in lieu of doing the more complex pathfinding. But we need to get that enemy so that when it's blocked, it doesn't just sit there all day and act goofy. So I'm going to go back into enemy here, and let's go under the enemy. We're going to go and grab some of the code that's here, and we're going to work with this. So we're going to find out, so when it's blocked, we're going to look for possible directions to go and then go in those directions and make some magic happen. So we're going to go grab all of the blocked code here. So I'm going to copy that and go at the end of chasing here. Just put a little line there, little line here so we know this is where we're pasting it. And then so now what we can do is, so if we're blocked, then we're going to, once we're blocked, this dot chasing equals false. And now, because remember, it only does chasing when we're not blocked. So if we're blocked, where it would sit there, so if we're not blocked, then it's going to try and choose a new direction. So let's see what happens. And we can see how this time it wandered through. But notice how now it just became a wandering monster. So it worked, but what we haven't done is we need to do a time event. So we're inside an object, so we have to make a reference to the scene. So this dot scene, and then now we can say time add event. So this is similar to what we did when we had the collisions happen in our handling collisions, where we added a time event to it. We can set up a time delay. We'll say, let's let it wander for 2 seconds. And then at that point, we will have our callback method. And our callback method is simply going to then change chasing back to true. And now didn't get the comma where I wanted. Let's delete that. Down arrow, comma, after the callback. And now we have to do our callback scope. That'll be this dot scene. So if you go back and look in the main game scene, we'll see we just were able to say this. We only want it to happen one time. But here, because we're inside an object, we have to kind of exit that object's knowledge, and that's why we are saying this dot scene instead of simply saying this. So if we look here, we can just say this and this. But now we have to say this dot scene. So that now kicks it out. So now it's going to wander, hit. So when it hits the top, and then now after 2 seconds, it's no longer. So now it's wandering, and now it's trying to get back to me. I'll hit the wall, go off, 1, 2, and now we can see how it's coming back to me. Oh, hit a wall again, 2, and now it's trying again. Yeah, it's going to be trapped there for a little bit. It's going to have a hard time getting to me. Now it's coming. It's the wall, 1, 2, boom. And, oh, got distracted when it nicked the corner of that tile, but that's okay. And now it's coming after me. So let's feed it a wall so it can't get to me. Boom, and now it's running away, and then I can get away from it. So we have the enemy following us, but if it's blocked for 2 seconds, it's going to then become a wandering monster, and then it goes back to being a chaser. So we're able to use that time event that's built into Phaser, which works just like the set timeout event in native JavaScript, to then call a function or method when that time quantity that we specify, in this case 2000 milliseconds or 2 seconds, has expired. And when that happens, then we make the statement change, and when that statement changes, boom, we're back to chasing. So it works pretty slick.